Tak, i lige måde.
I'm waiting for the go from my colleague.
I can see participants tickling in.
Yeah. Oh, and the Sirena, they are testing them today.
Yeah, same here. Yeah, also here in Odense right now.
Very, very, and the bells of Rådhusklokkerne. Good. Welcome to TITBITs today. Today we are going to talk about shipyards and shipbuilding. So, as I'm back in the office for today, we are slowly going back to the offices at Marlock. I found this old Lego ship that was a little bit destroyed by some kids that has been to the office with their parents, one of my colleagues. So it needs a makeover. So what if I could do a test for this makeover with a real ship, not this Lego ship, in a kind of parallel world, in order to avoid failure or errors when I was reconstructing or doing a makeover of my ship? Wouldn't that be great? Oh, this is what you're going to learn about today, and you're going to pay attention to a word or concept that you're going to get to know today, which is the digital twins. This is the tidbit about digital twins. I really love the words. And we are going to talk about robots and digitalization. So two very, very hot topics and this new word. So how is this snack served today at the premises of Marlock here in Amaliegade? Well, tidbits, as many of you already know, it's 15 minutes of presentation, followed by a 15 minutes Q&A. We kind of like it to do it cozy. That's why we have no blurred backgrounds or logo backgrounds. We have it just from, usually it's our home offices. It's in the case of Christian, but here is in our offices. That's why it's a little bit boring behind me today. But it's a little bit of TED Talk, you know, the 15 minutes concept, combined with a talk show. So let's make it cozy, and you can just lean back and relax at home. And I hope you also grab your lunch and the opportunity to have your lunch together with us while Christian is serving his nice and interesting knowledge just in a few seconds. So I'm Henriette Dybkjær from Marlock. I'm the host for today. And in my studio, I have Christian Schlette. He's a professor from SDU, Syddansk Universitet. So let's have a cheers for an awesome tidbit about Lego and robots and a lot of great things. The stage is yours, Christian.
Well, thanks for the introduction, Henriette. And yeah, welcome to this tidbit episode. Actually, I also brought a Lego robot that can help with fixing the ship maybe. And in my presentation today, I also want to try to tell a story that is starting maybe with Lego and the KUKA robot that we have made from Lego here. And is then making a link to robotization and digitization on shipyards. In particular, I'm going to talk about our project, ShipWeldFlow. Involved in ShipWeldFlow are two companies probably familiar to you, OMT, Odense, Maritime Technologies, and Inrotech. And SDU is in this project, and I can see in the attendees that there's also a daughter from SDU Mechanical Engineering and Maria Lützen. You know them well. They are an established part of your community. And together with Maria and daughter, we are going into this project, ShipWeldFlow, and I want to talk a bit about this project and what we're up to in this project. So it's three components coming together. So on the one hand, we have the ship and shipyard design coming from OMT. And just to give you an example, they do everything in 3D already, and they are actually quite familiar with having a digital twin. I will come to this term later on, but a digital twin of the ship that they are going to build. Then at SDU Robotics, I'm working on modeling and simulation and digital twins as one method of modeling and simulation of complex robotic systems. like the one that is depicted here. I will come to a different example later on where I explain a bit more what digital twins are actually about. And then the third partner, Inrotech, you know them well. They are also part of the Odense robotics community here. And they are developers of robotic welding equipment for shipyards mainly, like the one depicted here, the micro twin. And together with our colleagues from SDU Mechanical Engineering, we went into this project in order to tackle the three main objectives here. So we want to develop digital twins for shipbuilding, and I will explain what digital twins are here in this case. And the digital twins are supposed to connect the ship design in 3D, as we have seen it with OMT, with robotic welding in the end. Then to have a simulation of shipbuilding performance with various shipyard equipment options. This means that if people have a shipyard and they think about which ship designs they can support to build, that they can make strategic decisions about the equipment and how to develop the shipyard in the future. Then to save raw materials, which is a big issue also in Marlock, in the community here, the Maritime community in Denmark, since, well, we also see the green transition and the benefits from working on the green transition. And we think that in combination, this link between ship design and robotic welding can actually also contribute to saving of raw materials, steel here. Since we can think of new ways of robotic welding and combine them with alternative ship designs that are up for, using less steel in the end. But let's start with a one perception of how we see the workflow from a ship design to the actual production or the building of the ship today. And this is already the ideal case. There are a couple of problems with it in reality. But the actual ship design happens in a 3D program. It's then a CAD, computer-aided design system that already describes the ship quite well. And if we're up for robotic building, then we select the robots for the yard, or we have some yard equipment on the shipyard that want to build the ship design. And this is then some yard specs, some specifications of what a specific yard can support with their equipment. And then we have an assignment. We take the different units that we have to build from the ship and assign it to the different stations in the yard. So we actually can break down the whole ship design into different bits and pieces we call units here, and they are all described in 3D data. And then there's a programming step. Someone opens the 3D data. There's also some automated support from some suppliers where the 3D part is then annotated with further information how the actual welding, the actual building is supposed to be carried out. And from these annotations, the manual annotations or automated annotations, we generate robot programs, and those robot programs are then fed into the actual robotic systems for welding. So this is the flow as we see it today, and this is the ideal flow given that the shipyards actually know about their equipment, that they can actually describe their equipment sufficiently, given that also this is one workflow in terms of one system that can support the transition from the different stages. In reality, and some of you may know that this is actually not the case on most shipyards or with most shipbuilding processes. So this is why we actually also want to support with our developments in the project the digitization aspect in order to have a stronger robotization effect in the end. Because wherever we have an arrow here coming out of a box, going into a box, there is often a transition of media. So there is some data transmission involved, and probably also different programs or tools in order to support this transition. For example, to export CAD data from a ship design and then to import it into some support tools for programming the welding robots. So this is the workflow as it is today, and we want to work on different aspects, mainly based on digital twins. And this is just a rough explanation of the term digital twin. because there are 150 plus definitions of what a digital twin actually is. But I want to give you my perspective on digital twins here. And my perspective is that a digital twin is a combination of various digital models and simulation and planning tools. So if you, for example, think of offline programming of robots, then this could well play into a digital twin, could be a component in a digital twin. We have a virtual replica of the actual physical asset on the right-hand side, and we can play around with this virtual replica with the digital twin and experiment with it as we would do with a physical robot. But we can, of course, because it's just a model in a computer, we can have many, many copies. We can have teams working in parallel, each with their own copy of the digital twin, in order to come up with new developments around this robotic system. And then this is how we do it at SDU Robotics. We have 3 different layers. We have a planning layer and a simulation layer where we can, for example, plan trajectories for the robots to follow paths without collisions, also in cluttered setups like the one shown here. Then we have some abstraction layer that is then taking care of mapping the outcomes of the planning to the real robots, to the physical robots. And this is then a so-called real-time layer where we have the contact to the control units of the individual robots in order to move the robots around. So a digital twin in this sense is a link to connect the digital models of our setups to the physical assets on the other hand. And this can be the product digital twin, for example, the ship. This can be the production system, like the robots here in this example here, and the production environment, because a shipyard, as you know, is also a highly dynamic environment where things have to be moved around, scheduled. You have a lot of logistics going on shipyards, so it's worth to have a digital twin of the shipyard and the production environment itself. This is actually an example now that I want to start with, coming from factory automation. So this is really conventional robotics and digitization coming from the area or from the field of research of Industry 4.0. And here we have a product coming from Lego that we want to connect to KUKA robots. And this development, this idea of the digital twins and how we developed it, was developed together with Lego and KUKA in this case. And what you see here is our digital twin at work. And the task that we are working on here, just as an example to understand and visualize a bit what a digital twin is about, is the support for assembling and disassembling injection molds from Lego. So Lego today still has no robotic support for the assembly and disassembly of injection molds. And they approached us to develop a robotic system, a support system that can work together with the operators so that they have some help of lifting the huge injection molds and then also screwing the bolts to torques. And such an injection mold easily weighs up to 500 kilos, sometimes even 750 kilos, and consists of many, many dozens of parts. So if this is a manual process, you need highly trained people, highly aware people who know what they do. And with the help of digital twins, we were able to develop a new process that we then use together with this real-time layer in order to drive real robots. And this is then the outcome in our lab, where we have a direct interaction of industrial robots and the collaborative robot. And one worker here, it's one of my PhD students actually working on this topic, where we see this interaction. This is just to give you an idea what a digital twin is. We have this setup in the digital space, the digital model that we can use for planning and simulation. We can have all sorts of databases connected to it. We can have all sorts of also methods of artificial intelligence connected to it. And then we use the digital twin to drive the physical robots as well. Now, let's make a big step from what we have seen with Lego and KUKA to what we are up to in ShipWeldFlow. And this project was granted last year in autumn. So we are now on our way for a couple of months only. And I have some first results that I want to share with you. But the idea is actually, so to speak, how to connect the product, the ship designs from OMT and the shipyard designs from OMT to the physical production systems, the robots from Inrotech and other suppliers. And let's start with Inrotech. So this is actually what they use today in order to program their robotic setups. That's a commercial product. That's an offline programming environment from Fanuc that they use in order to program their microtwin. So the microtwin is basically a gantry with two Fanuc robots for welding hanging from it. And they use this system in order to test new trajectories and program new trajectories in simulation, what is called offline programming. And by connecting to this, which is actually sort of their control system of the robots, we get this one here, which is a digital twin in our software that we use at SDU Robotics in order to build digital twins. And what you can see here is we have an environment around, so we have a hangar. You can, we have some strong shadows here, but you can see the microtwin, it's extending over the full length. The gantry is over here. We see the two robots. And what we also see is we have some sensor simulation. So the laser scanners mounted on the gantry, we can use their input from the physical scanners, or we can simulate the input in order to develop the reactions of the robots in the digital twin first. So we can play around with several scenarios here in the digital twin, something that is not possible in only the offline programming system. But we can combine it with a production environment, the hangar. We can combine it with different other robots in the surroundings here, in order to have exactly this digital twin that we want to have to help Inrotech to have a better control over their robots. And then for OMT, it's a bit different. They are already quite advanced in 3D design. So this is actually an example from their ship designs, and they just highlighted, I think, the pipes and tubes in one of the ship designs here, just to give you an impression. So such a digital twin of the product of the ship can easily have millions of parts. And for each of the parts, we not only need to know the materials, specifications, the location where it's supposed to be, but also the assembly sequence. When is it supposed to come in place? Plus, who is going to put it there? So who is going to, for example, do this welding seam? Which equipment is going to carry it out? And the design is one part, but this is quite static. And together with OMT, we're actually looking at analyzing the ship design and how this is then running through the different stations on the shipyard in order to make the full ship for real, just based on digital twins again. And then just to give you an impression, this is, well, probably not telling you much, but what we do is for each of the parts that play a role in the ship, we actually make a diagram, a simulation of the full process of building the ship and how the different parts are then running through the different stations, the performance of the stations, and to identify bottlenecks in the process, up to the point where we then end up with, in this case here, part 97, which is then already a sub-assembly of a full ship. So this is the type of digital twin that OMT is interested in. And then if one of the stations, for example, here, the micro panel assembly in the middle is then a micro twin setup from Inrotech, then we can go into the details of the micro twin and we can actually push the geometries of the parts that we are working on directly to the digital twin for the micro twin, many twins in here, in order to measure the performance directly with a robot setup that Inrotech brings to the market. Well, to wrap it up, we in ShipWeldFlow work together with OMT on the Maritime technology and Inrotech, both located here in Odense. We are working with our colleagues from SDU Mechanical Engineering, and I can see Dorte and Marie in the audience, and you know them well. And we have three objectives that we pursue, which is digital twins for shipbuilding, the product, the production systems, and the production environment. And maybe you get a better idea now what digital twins are about. in contrast to just a simulation or just a digital model. And then we are looking into how to connect the digital twin or the digital models of the ship design directly to fuel optimizations of the process flow on shipyards, and then also the very detailed flows within the setups from, for example, Inrotech in our example here. And this with the goal to optimize the weld flow as we see it in the shipyards today, and also with the aim to actually reduce the raw materials necessary in the steps. Well, I think this is pretty much my 15 minutes. And yeah, I would hand back to Henriette.
I'm coming back here. Yes. Thank you so much. I'm just put the gallery. Yes, here we go. Welcome back again, Christian, to the shared studio with me. It's really amazing. I feel so privileged that I have all you great associate professors and universities here in the TITBIT studios, because there is so much interesting research out there. It's really, really amazing. This is what TITBITs is about. It's about sharing these small guldkorn, as we say in Danish, with all of you out there, because we have a broad palette of stuff that we are serving you for your lunch, and this was absolutely amazing. This is how did this project start? How did you get the idea of the digital twin?
Well, the digital twin is actually a term that comes from the field of Industry 4.0. And Industry 4.0 is very much exactly about the digitization and robotization of factory automation. Yep. If you think, for example, of your mobile phone, just as an example, right? It consists of many components, and if there's just a tiny change, actually someone would have to sit down and reprogram the whole assembly line in order to make this change also available in the production. And this is exactly where Industry 4.0 comes in, that it's about handling the complexity of maybe also products that are very complex on itself, but also where we have many variants of the same product, up to the point that we sometimes only have one of a kind. And this is exactly where we see the need of the maritime sector. Actually, also the same goes on in the energy sector and construction sector. And then we are looking in cases in those sectors as well, where we have this one-of-a-kind production. And then we call it building, because it's still so manual what we have in the maritime sector. And we have so many manual steps, only a few robotic stations. And this is something where we actually look back. We had the Odense steel shipyard, and I learned a lot about this environment when I came to SDU in 2017. And it's actually old partners coming together here. So the people from OMT, the people from Inrotech, they used to work together on the Odense steel shipyard. And the yard was very advanced in robotics. This is to some extent also due to the Maersk Institute that was founded. And then I'm now a member of. So we are actually bringing together some of the old ideas that were already around at the Odense steel shipyard, and just combine it with the new research and outcomes that we see in Industry 4.0.
Very interesting also background for the robotics cluster that you have at Fyn, that actually comes out of the shipyard. I didn't know that. Very interesting. Thank you for sharing that knowledge. We have got a few questions from Thomas Olsen. He has written to the panelists, so that's why you out there can't see them. So he says, very exciting. Could this technology also be used for scrapping? So such as disassembly of ships and rigs? Certainly.
And I think thinking about green transition, saving materials, then we have to think about how to build up something, but also how to scrap ships, for example. It's no option actually for us that we see that ships, tankers are onshore somewhere in India, where people just go over it and disassemble it manually under hazardous conditions. But we should actually think the full life cycle of our products And this is also true for ships. Why not bringing them back, making reuse, recycling of the materials involved? And if we have a higher degree of automation and knowledge, also keeping track of the individual parts in the ship that we use to build it up, then we can also use the very same knowledge to disassemble it again. We are a bit back at Lego, but from a different perspective, right? It's coming together and being maybe disassembled again into individual bricks that are reusable.
It makes perfect sense with the Lego comparison. Yeah. What about, I was just considering like the cruise industry now during the Corona, the COVID situation, we have seen a lot of cruise ships who was out of use and they have to be scrapped. So we saw like photos with 5 or 10 cruise ships in in Turkey, or where they were going to scrap them. What about the cruise industry? Have you considered for that one? Because that must be a lot of materials, much more complex ship rather than a ship from the merchant fleet.
I think you're right about the complexity. Yeah. And what we are aiming for right now is also mostly the frame structure of the ship, right? There's a second step, which is then about outfitting the ship. So everything that needs to go inside, like, well, if you go on a cruiser, you expect a nice cabin, not just steel, right? So everything that needs to go in, this is an outfitting step, but I also see there a big future for robotics to help with those tasks as well. Since we can restructure the process of building a ship a bit, so that we wouldn't have to build the full structure first and then move in just for the outfitting with a second type of equipment, second type of also knowledge with the workers and experience and expertise. But we can actually think of combining the two steps. For example, what we have seen as an example with the pipes, to already think the assembly or the outfitting of the pipes as part of the assembly of the full structure then. So I think there is a potential also for more complex ships than just the big tankers or container ships, right?
Because this brings me to the next question, also from Thomas Olsen, which is, are there parts of the shipbuilding process that are too complex for the robots?
Yes and no. I think I would take it as a challenge, right? I mean, we have different answers to that. It's quite obvious. There are things that can be done easily. And this is also what is already happening in this line production that we see on shipyards. And then if we go into the details, like now I mentioned outfitting of cabins, for example, then we are coming closer and closer and closer to what is already known in the automotive industry, where we also see robots, for example, putting in the car seats and the armature board and whatnot. So I think this there is some it's actually growing together. So we have the large structures coming together with the small structures where we already have a good knowledge from factory automation how to handle those cases. However, I think there is also other parts, like, for example, complex parts made of steel, but I see that actually Peter Nielsen was around. I don't know if he is still around, but so there are methods like additive manufacturing from steel. So using the same technologies as we see it in welding, but to add material in order to build up complex shapes in a sort of additive manufacturing step. I think there's still a lot of potential for robotics, because many of it is just carried out manually today.
Makes perfectly sense. Christian, unfortunately, it has come to an end, and we need to leave our nice participants to some other online meetings or wherever they are going after this session. So I will send you a warm thank you for sharing these great
You're
results.
welcome.
It was really, really inspiring. Also, what you explained about the history of the robotics cluster on Fyn and so on. sometimes it's not only the technical stuff that matters, it's also history here.
Yeah.
So thank you to all of you out there for listening along, and thank you to Maritime Research Alliance, Thomas Rosling Olsen, who has helped us doing this special spicy tidbits on every Wednesday with researchers from the universities out there in the Danish landscape, considering the maritime research. We will have more spicy tidbits for you next week. Actually, Tuesday we will have Josef Guerrero from Aalborg University, and he's going to speak about microgrid technology. I still don't know what it is all about, so I'm looking very much forward to dive into that one. So from digital twins to microgrid technologies. And then on Wednesday, we are going to have another researcher from Aalborg University in the TITBIT studio. She's called Agnieszka Nowinska. And she's going to speak about something a little bit more commercial, because it's about the fixtures in the container shipping market. So it's a little bit different from the tech angle we had today and are going to have on Tuesday. It's still at 12 o'clock, so just tune in. My colleague, she just posted where you can read about future tidbits, and this one and also the future tidbits are all recorded and put to our YouTube channel, and that's where you can dive in and look up for all different topics from the maritime world. It's really a lot of goodies. There are a lot of goodies waiting for you in there. So thank you so much, everyone, and we are looking forward to seeing you again, and have a nice day in the gray weather, and happy 5th May for all of you here in Denmark, by the way. Hi.
Hi.